The Chesapeake Bay Water Project by Jessica Marshall, Samantha Benson, Alexis Chua, and Shannon Cunningham. The Chesapeake Bay Watershed General Information. The Chesapeake Bay is located in Maryland, Pennsylvania, Delaware, New York, West Virginia, and Virginia. The watershed is very large in size, for it is about 64,000 square miles. This watershed is home to over 17 million people. These residents each live only a couple of miles from some of the bay's most important rivers. The Chesapeake Bay has a major fishing industry due to the many different species of fish scattered around the watershed. There are about 150 rivers, creeks, and branches in the Chesapeake region. Some of the major rivers include the Susquehanna, the Chester, the Choptank, and the Potomac. Biological evidence of pollution in the watershed. There is both biological and chemical evidence that supports the claim that the Chesapeake Bay is polluted. The first piece of evidence is agricultural sources. Ammonia is usually produced from animal manure during agricultural operations. The ammonia floats through the air and, if breathed in, can irritate humans' eyes and lungs. If ammonia affects us badly from the air, it will pollute the bay badly also. Ammonia polluting the air can result in algae blooms, which will harm sea life.
There is a lot of evidence of chemical pollution in the watershed. The two major reasons come from nitrogen and chemical contaminants. First, nitrogen aids the growth of algae blooms, and this can harm the Chesapeake Bay because algae grows way too much and it can block the sunlight from reaching the animals and plants in the waters. It also harms the air that comes from machines or cars, and it travels to the bay, polluting the air surrounding it. Chemical contaminants are also affecting the Chesapeake Bay airshed. Chemical contaminants include mercury, PCBs, and PAHs, and they pollute the air surrounding the bay and can lead to many major issues.
What exactly is water quality? Water quality is defined by the condition of the water by observing chemical, physical, and biological characteristics. Scientists test several different things to determine the quality of the water, and you will see these tests in the next slides. In addition, this picture shows how water quality can be determined over a long period of time. First, precipitation happens, and then the runoff and discharge to the streams, which mixes with the soil water and pollution in the area, and this can go into the streams and waters, and it can be affected through months, years, and decades. There are many tests to determine the water quality of the Chesapeake Bay watershed. The first test is temperature. The chemistry of the water is affected by the temperature of the water, and this is because the temperature decides what kind of animals can live in these conditions. For example, warm water holds less oxygen than cold water, and this directly affects the organisms because it can decide if they can live in these temperatures or not. The next test is dissolved oxygen, and this can be tested by using a dissolved oxygen probe. This test is measured to find the amount of oxygen that is available for organisms in the water. Healthier water generally has a high rate of dissolved oxygen that allows the organisms in the water to breathe. The amount of dissolved oxygen is affected by water temperature, pollution, how fast the water flows, and gravel composition.
Several other tests that can be used to determine water quality are nutrients, toxic substances, turbidity, visual surveys, biological samples, and pH. First, there are nutrients. There are two major nutrients that affect the water quality of the Chesapeake Bay: nitrogen and phosphorus. Although these two nutrients are healthful, too much of them can result in algae bloom, preventing sea life from having any contact with the sun. Also, an excessive amount of nutrients in the bay can alter water temperatures, pH, and cause the appearance and odor of the water to become foul. Second, examples of toxic substances found in the water are metals, pesticides, and oil. Not only are they harmful to the underwater creatures, but they are also harmful by changing the water quality into a worse state. Visual surveys is another test to find water quality. This would work by simply observing the vegetation in the Chesapeake Bay ecosystem. Visual surveys is simple. If there is a large mass of trees and shrubbery surrounding the water source, the water must be healthy and have good quality. Next is biological sampling. This is similar to visual surveys, but instead is dealing with organisms that live in the water instead of surrounding the water. To test the water quality using biological sampling, you would have to observe the different types of organisms. Only some types of organisms can live in clean water, and only some organisms are abundant in dirty water. If organisms that usually live in clean water are observed in a water sample, the water source is healthy and clean. Finally, the last one of the most common ways of testing water quality is finding the pH. pH stands for potential of hydrogen. According to its name, pH will determine the amount of hydrogen in the water. pH can range from 0, meaning it is very acidic, to 14, meaning that it is very basic, with 7 being neutral. If the water is tested and has a pH that ranges from between 6.5 to 8.5, the water is healthy. Changes in the pH will change the water quality and will affect life in the Chesapeake Bay.
Who contributed to the water quality? Humans are the largest contributors to the current poor quality of the Chesapeake. The water is poor because of an excess amount of nutrients. These nutrients come from various human things such as chemicals used for nearby agriculture plots, air pollution from cars and factories, and other home-used chemicals. They usually reach the water by runoff water from storms or soaking into the ground. Humans have also introduced new species to the bay like zebra mussels and blue catfish that can cause harm to the ecosystem. The kinds of chemicals that are polluting the Chesapeake Bay include polychlorinated biphenyls. These are industrial chemicals that make their way into the water by spills, leaks, and improper disposal. There is also polycyclic aromatic hydrocarbons that are entered into the environment by air pollution of carbon-related compounds, such as exhaust from cars, cigarette smoke, open fires, and so on. Pesticides also contribute to the quality, as mentioned before, by runoff from nearby farms in the watershed. Lastly, mercury is also a hazard that is introduced into the Chesapeake Bay by coal-fired power plants. And to wrap this up, these are our works cited pages. Thank you for listening.